try to clarify some things, revisit some things that I mentioned on day one that now that we have some context to talk about them in, I want to just remind everyone of a few things and clear up some misconceptions that are floating around there. So first, I may have started a rumor, and specifically in this section, I said similar things in all sections, but this one I said something like, if you have 50 submissions in Autolab, you don't understand testing and stuff. I got all dramatic about it. Might have gone a little overboard with that one, so let me explain a little more about that, because there's starting to be some panic out there. So these are going to be looked at in a case-by-case basis. If you have 50, 100 submissions, there are scenarios where that's perfectly valid, and there are scenarios where that's not valid. That's the reason I can't just shout out a number and say, if you're over this number, because if I could do that, I would just use that number of submissions on Autolab. But if you have, say, 100 submissions, what I'm really looking for is I want to know that you are really understanding the content. If you have these 3 bullet points and that you're working on the code in good faith and really understanding the material and trying to learn the material. So what I'm looking for is if there's 100 submissions and I look through your submissions and you're clearly using Autolab as your tester and your compiler in some cases, and you're just making a change and basically using guess and check against Autolab to try to work on your code. And you're not doing your own testing locally, or you add one test case, resubmit, add a test case, change a line, resubmit. That's the behavior I don't want to see. I want to see you really thinking about what you're doing, thinking, okay, I made a submission, it didn't get credit, let me see what I can improve on my code and then resubmit. That's the behavior I want to see, that you're really thinking about what you're doing. But there are many valid reasons why you might have a lot of submissions. For example, I have that, I can't believe it, I'll talk about it in the slides too, but I have that capital L in flashlight that drives me nuts. I made a mistake like that. But I had a capital L in flashlight. Flashlight's one word, that L should be lowercase. So if you have 100 submissions, your first few submissions look pretty good, but then you had 100 submissions just trying to figure out something that I did kind of weird in the question, or maybe you interpreted the question differently than what I intended, but in a completely understandable way. You can rack up 100 submissions trying to chase that last incorrect solution, but you have a false premise that you're working on and just never be able to get it. That's perfectly understandable, and you can have 100 submissions and not be that big of a deal. In those cases, I can look at, like, say your 5th submission or so, and that one looks almost there, and it's almost the same as your 100th submission. You're just trying to make those little changes to get that last little thing to satisfy Autolab and the autograder. Now that's completely different than just guess and checking and banging against Autolab like that. So 100 submissions can be very different in 2 different scenarios. So I just want to clarify that. There's no such thing as working on the code and wanting to improve it, and then what I'm seeing some students doing is getting up to like 20 or so submissions and then starting to get nervous. Oh no, I have too many submissions. I don't want that behavior. I want you to use Autolab as the tool that it's intended to be used for to get that feedback, just not abusing that feedback and only relying on that. So hopefully that clears up some of that. The late lecture questions, there's some misconceptions on this. There were, I see some students on Piazza, and I can understand this, thinking, why would I submit late? It's giving me a 0 in Autolab. I just want to clarify, the complete, that bit that flips to 1 for complete when you have all of the objectives for a lecture question, doesn't really mean that much. That's not a point, that's not score. I saw there's a poll on Piazza right now of some good chunk of the class wants 8 lecture questions a week, and then some options between them, so you pick 6 out of the 8. And having some lecture questions count for double points, and being able to get the points for late submissions. There's no such thing as points in this class. There's no such thing as credit. There's the learning objectives complete and the application objectives complete. So when I'm going through the learning objectives, which I'll do starting Friday, once all the labs are done and I have all the information for this learning objective, I'm going to look at all the information I have and make a decision based on these 3 bullet points on whether you've completed this learning objective or not. I don't care if you submitted a lecture question late. if you're worrying a lot about that 1 or 0 in AutoLab, say there's a scenario where you submitted a lecture question 1 minute after the deadline, you got the 1 and then it said -1 for a late day, or you submitted 1 minute before the deadline and you got the 1 in AutoLab. Why would that ever factor into my decision when I'm deciding, can you do these 3 things? That 2-minute difference, yeah, AutoLab gives you different output. That's quite meaningless. The only reason I have it give any output is so I have one thing where I can look at a glance at the gradebook and I can see how many students have at least gotten to that point in AutoLab. So I can get a quick general feel of how the class is doing. Really doesn't mean anything. If you submit a day or 2 late, again, how does that factor into my decision when I'm deciding if you understand these things? The deadlines are pretty soft deadlines, with the exception of homeworks. Somebody brought that up in the other lecture. With the exception of homeworks, the deadlines are what I refer to as soft deadlines. That's my recommendation of where you should be at that point. When the lecture question is due, if you can't do that lecture question by that time, that's a good indication that you're falling a little behind. You need to start catching up, because if you can't do that lecture question before the next lecture, is why they're due before the next lecture. If you can't do that lecture question before the next lecture, you're not going to understand that lecture. If you can't do today's lecture question, you're not going to understand Wednesday's lecture. And that's why the due dates are where they are. That's where you should be. If you're not quite there, especially if it's a lecture question or 2 out of the 6, that you don't finish by the deadline, but you watch the next lecture, then it starts to click, like, oh, you know what? Unit testing is starting to make sense now that we're talking about references and objects and stuff. And then you go back and finish that lecture question. I can just see that, okay, you did that lecture question, it was just a little late. If I'm looking at 6 lecture questions, 2 of them were a few days late. It's no big deal. You still did it. You still did these things. Yeah, question?
When it comes to lecture questions and unit testing, like say if you get all, like you pass on your test, pass on your own test, and full functionality, but you're missing like one obscure test case, do you take that into consideration?
Yeah, so that's the big point of what I'm making. I'll take everything into consideration. So if you're just missing one of the incorrect solutions, and it depends what bullet point I'm looking at. Say you're missing one of the incorrect solutions on one of the lecture questions, but you got them on all the other lecture questions, and maybe that lecture question was about references. So the batteries, references, you got the code. The code's great. You got passed all my tests, but you're not getting one of my incorrect solutions completely checked. Well, I can still look at that and say, well, that's good evidence that you understand references, but not, maybe not so much for the testing. But I got 4 other lecture questions where I asked you to write unit tests on. I can look at those 4 and say, well, you nailed those ones, so you got unit testing. I can make decisions like that. I'm going to look at all the evidence I have and make a rational decision as a human being. Can you do these 3 things? So I don't care about whether AutoLab says 1 or 0. I don't care about the testing objectives necessarily. I can use all that as evidence to build the picture of, do I think that you completed these 3 things? But no individual thing is going to make or break my decision that, oh, you got that 0 in AutoLab, so you obviously don't know anything about that. Oh, you could have a really good submission that just has one little mistake because the way I worded the lecture question was a little weird and you interpreted it a different way than I intended. I'm not going to hold that against you. Yeah, question?
When do you find out if you're passed project?
Yeah, so that's the next thing I want to talk about, the kind of time frame and logistics of this. So I have your 6 lecture questions. Of your 6 lecture questions, your lab activity, and in your TA interview, your interview with the TA. So at the end of the week, I'll have that for everybody. That's when I'll start looking at things. I might just take a glance at stuff before then, but I'm not going to wait. I'm going to wait until that last lab before I make any decisions. Wait till the last lab. I'm going to have all your information, and I'm going to look at that and decide who's completing the objective or not. Now, the best way to think about how this is going to work is try putting yourself in my shoes and look at the situation that I'll have. I got 379 students, and I have all this information, and I got to make decisions. So the first thing, and the easiest way to complete these objectives, anybody who has all 6 lecture questions, even if 1 or 2 of them were late, Their lab activity looks pretty good in the TA interview. There's nothing that stands out as a red flag during that. That's an easy, yep, completed. If you're in that category, I don't have to look any further. I'm not even going to look at your number of submissions. I'm not going to look at the finer details of that. For the students who maybe missed a lecture question, maybe there's something in their interview where it didn't seem like they really completed all three of these, and I'm looking for each of these individually. I'm going to try to check off all three. So if you only missed one of these, I can give you that feedback. Hey, this is the bullet point you missed. We still got to work on this one a little bit. So maybe I look at your lab activity and your interview, and I'm just not quite convinced that you got the stack and heap memory. That's when I can start looking at more information. I can start digging a little deeper. That's a bad example because I don't have any other information to go up. But maybe references. I look at everything and I'm just not quite sure. That's when I can look at number of submissions. Okay, pull up your 5th submission. Because obviously 379 students, I'm not going to be doing that kind of stuff with every single student because you won't get your grades back until, you won't get your program execution completion until after the final. I just wouldn't be able to do that. It's just impractical. But when it's a borderline case, I gotta get my thoughts. Okay, I got this. So the easy cases, you got everything, just everything looks good, nothing stands out as a reason for me to not say you complete all those. Completed. Objective complete. Then there are the easy no's. If you didn't finish half of the lecture questions, maybe you skipped lab, maybe the lab activity, you just said, yeah, stack and heap are cool, and didn't give me any information on it, and maybe you did kind of okay on the TA interview. Well, that's an easy no. Okay, you didn't even do half of the stuff. Then everything in between, that's where I'm going to start digging. That's where I'm going to look. Okay, I need to make a decision on this, on each bullet point. I'm convinced on 2 of them. Let me see about the 3rd. How about any submissions? Look at all that stuff. That's where I'm going to start digging. I'm going to make those decisions as a rational human being. I can't make those very fine-tuned decisions with everybody, but that middle, the tough cases, those middling decisions, that's when I can dig in and make a rational decision as a human being. Does this student understand these 3 things? And my goal is, if you can do these 3 things, you know in your heart that you can do these. You understand the hell out of stack and heap. You know how references work. You can unit test anything. You shouldn't have anything to worry about. My goal is to have you have a very stress-free course where you can just focus on the content. In that case, if you're really understanding the material and you're learning this material, awesome. You shouldn't be stressed. If you're in that case and you're stressed, come talk to me. I want to hear from you. I want to know what I can do to make the course less stressful. That's what there's a lot of stress going on right now. That's why I want to give this talk in each lecture. So I can make those decisions. When I make a decision, this is just the first round of your first opportunity to be able to complete this objective. So program execution. I keep saying this, you have lab activity, TA interview. That's the only places I can test this 3rd bullet point. But that's only for this first round of going through this. At the end of next week, you got everything and it looks good, checked out. If you don't, I mentioned on day 1 that you have more opportunities to complete that learning objective besides the final. Of course, you have the final as your last ditch effort. But there's other opportunities, and I don't necessarily mean additional assignments. Like I won't say, okay, for everyone who didn't complete this 3rd bullet point, here's another thing you can do. It's more content later in the course that's going to depend on your understanding of program execution. So for example, when we get to immutability, and when we get to linked lists, and when we get to trees, we're going to pull up the stack and heap again. We're going to be talking about memory at different points throughout the course. So maybe you didn't get this bullet point by the end of next week. You checked off on the first 2. You'll get that 3rd one. When we start talking about immutability and we're looking at memory diagrams again, you can do something during that, the lab activity, homework verification, whatever's going to have stack and heap, and say, hey look, I did this. I understand stack and heap now, even if I didn't on week 4, and I can check you off for that. And be like, oh yeah, great, got that 3rd bullet point, learning objective complete. So you have more opportunities just naturally built into the course. We're about to step into object-oriented programming. And we're going to use object-oriented programming throughout the course. We're going to use that a lot moving forward. So it's not like you have 6 lecture questions, lab activity, and a TA interview, and that's your one chance to do this, there's going to be a lot of opportunities because we're going to use object-oriented programming after we learn that. We're going to use it throughout the course. So there's going to be just natural opportunities to prove that you completed the bullet points later on in the course. And the last learning objective, the content stops like with 3 weeks left in lecture. That's intended because that gives us 3 weeks to have more opportunities to get those that last learning objective specifically, so you have more opportunities to get that thing done. The project, that's going to be all about applying that last learning objective, event-based architectures, is going to be a huge part of that. So by doing the project, you can show me that you got that last one. And also, specifically, I want to pick out testing. I ask you to do testing on every single homework. Every single homework is going to have those 3 testing objectives. If you don't get this bullet point through the lecture questions in lab this week, but you do one of the homeworks, maybe you do physics engine and you get all of the testing objectives and all my correct and incorrect solutions and everything, and get through the homework verification lab, everything's fine there, you take the homework quiz and everything. I would have no reason to not check you off on that bullet point, even if you didn't do those lecture questions where I had unit testing. Again, I'll repeat it one more time. I'm going to look at this as a rational human being. If you do testing here that's way more complex than the testing I asked you to do over here, I mean, this can overshadow what you didn't do over here. The lecture questions are mostly there to guide you along, to make sure that you're staying on track. It's not, here's a lecture question, it's due tomorrow. You didn't do it, you're done. It's not like that. It's not, a lot of students are taking it like that, and I understand, because that's how it would work in a lot of courses. It's a deadline. After that deadline, you don't get those points anymore. That's not really how this course is working. So I just want to hopefully clear up a lot of misconceptions through that. I'm trying to think, make sure I got everything there. Oh, the homework assignments, so all that's with learning objectives. I'm saying 5 learning objectives, complete them all or fail. That on the surface is very stressful, so I'm going to do everything I can to make that less stressful, give you opportunities to show me that you do understand these things, that you can do the bullet points. The application objectives are a different story. That's where you're earning your grades. I mean, if you want an A, you got to perform. The deadlines are hard deadlines, that's going to be a bit more enforced. But if you get the primary objective, so the whole goal of the application objectives is, can you take the course material and apply it to solve a real world problem? So if you can take program execution and solve physics engine and get the primary objective, I'm not that concerned about your 3 objectives leading up to that. This question has been coming up a lot. Well, I got a 1 in auto lab, do I have to finish all those incorrect test things? The 3 testing objectives, that's kind of my scaffolding to guide you towards that primary objective. If you complete the primary objective, I won't just say flat out that you're good, but if you complete the primary objective and don't complete the 3 objectives leading up to it, you won't just get a 0 on the homework. Actually, I think this is a lecture where I talked about this a lot, wasn't it? Was it? Maybe it wasn't. But anyway, won't just say, no, you didn't get that application objective, sorry, because objective 1, you didn't really do what I wanted you to do. If you get the primary objective, at the very worst, you're going to get some feedback that says, hey, you had like 0 testing, dude. Can you show us something? Is there something more? But you'll still be in the running. You won't just get a surprise 0 for that application. If you submit the primary, the very worst is you'll get feedback. You'll probably just get feedback that says you're good to go. But there's a possibility you'll get feedback that says, hey, can you do this one more thing to just really show that you know how to apply the learning objective? I think that's everything I want to get out there. Oh, and don't DM your TAs on Discord. I got a request from my TAs to tell you that. They won't respond. They have no obligation to respond. They don't even have an obligation to be on Discord or Piazza. But some of them do. Definitely don't DM them. If you need to ask a question like that, private post on Piazza is the way to do it. That's our protocol. DMs on Discord. I tell them not to answer those. You have a question? Okay. All right. I think that's everything. 3:20. We probably studied through the whole lecture. Any questions on any of that? That's the big thing worth repeating. My goal, my job, I see it as my job anyway. If you can do these 3 bullet points, and you're not just completely checked out of the course, you're putting a reasonable effort into the stuff, you should not be stressed. My goal is to make sure that you're not stressing out. If you complete these 3, if you can do these 3, my job is to identify that and give you credit for it. So if you can do these 3 things and you're not getting credit for the lecture, the learning objective, once I release everything next week, let me know. Yell at me after class. Come to my office hours. You can try to email me, but I'm slow with email. No questions? I got 1 thumbs up. I'll take it. All right. So let's get into some new content. With all that, object-oriented programming. We're moving to our next 3 bullet points, our next learning objective. And the 3 big things here: inheritance, polymorphism, and the state pattern. So today we're going to talk about inheritance and what that means. And overall, it's object-oriented programming and then functional programming. These are our 2 programming paradigms with the goal of organizing our code and organizing our programs in ways that make them easy to maintain, easy to work with, and easy to expand. If you want to add new features to your program, how do we do that, and how do we keep things in a nice state? As our programs get large, how are we going to handle all this code without having it just all in one chunk? Let's organize things a bit better and make our code easier to work with. So to that end, today we'll talk about inheritance. On Wednesday, we'll talk about polymorphism. Friday, we'll talk about an application of polymorphism using JSON in a strongly typed language like Scala. And next week is going to be all about the state pattern, the state design pattern, which is that 3rd bullet point. So changing the behavior of a program based on the type of an object. So I should have the homeworks up by Wednesday. I was hoping to get it done today, but I was working on that lab real late last night. The homework will be to solve an objective, do a real-world problem without using control flow. No ifs, no loops. And that's where this 3rd bullet is going to come in strong. We want to change the behavior of a program. What happens when we can't use an if? We can't say if condition run this code. We're going to say, hey, some state variable that holds a reference to an object, do your thing. And based on the type stored in that variable, a different method will be called based on what object is in that variable. And then we can change the object that's in that variable to change the behavior of our program by changing the type, changing the state variables of that object. And we can get quite a bit done with no control flow, no conditional code being executed. So that's what we're up against. That's what we're trying to do in the next 2 weeks. So with that, let's do exactly that. Inheritance. So lecture question today, functionally, it's the same lecture question as last Friday. We're talking batteries, we're talking boomboxes, we're talking flashlights, and my goodness, I cannot believe, I said it once already, but I cannot believe I had this capital L. I'm so sorry if that caused frustration out there. Flashlight is 1 word, it should be a lowercase l. I have the typo. I preserved the typo in this question just for consistency, but I noticed it last night when I was putting this one together. Oh my goodness, flashlight is not 2 words. So that should be a lowercase l. I made it a capital. I can't believe that. But we're bringing back the boombox, flashlight, and battery. But now, when you worked on this lecture question on Friday, or on Saturday, you notice that in boombox and flashlight, there's a lot of functionality that's very similar, and one entire method that's exactly the same. There's a lot of common code, but we have 2 different classes to store those. Now what we want to do with inheritance is identify that, hey, we have some common code in these 2 classes. Can we not type this twice? Can we not have this duplicate code in our program? That's what we're going to do here. We're going to create what's called an abstract class named electronic. That's going to store all of the common functionality between boombox and flashlight. And then boombox and flashlight, through inheritance, are going to extend electronic, grab all of the functionality of an electronic, and then only store the code that's different between the boombox and flashlight. So we're effectively factoring out all of the common functionality into an abstract class, and then leaving only what's different in these classes.
Is there,
Oh yeah, and put that in a different package, op.electronics. So you can preserve your previous lecture question. You start by cut and pasting battery, never change, but battery, boombox, and flashlight into this new package, and then start modifying your code to fit this lecture question. Yep.
The electronics classes, and that's not a different type of class, just the abstract part of it is nothing different, it's just a normal class when it's used in.
You would create a separate file for it, if that's what you're asking.
For the
It's a
electronic
whole,
classes.
yeah, electronic is a whole separate class. Same file, a separate file, mostly the same as these other classes. But you're gonna have the word abstract here, and your use method can be abstract, and we'll talk about what that means today. We shouldn't know what extends, inherits, or abstract is yet, but you will in half an hour here. So, I couldn't remember, I didn't check. I don't remember if I showed this diagram before. I might have removed that slide from earlier lectures, but this diagram, we want to understand what this is doing, and I'll show this again at the end of the lecture to figure out what this actually means, in case you've seen this before. You've at least seen it in the documentation that I link from the course website. What does this mean? What are we talking about with all this type hierarchy? So let's bring in an application here, a problem that we want to solve. We want to set up some core mechanics of a game that we probably, to be honest, we probably won't get to, we won't build this one out fully. But let's build the mechanics of a basic dodgeball game. You have players, you have balls that exist in this world that you can throw at each other. When a ball hits a player, which we won't build the lose health functionality, when a ball hits a player, they'll lose some health, and they can collect and consume health potions to replenish their health. So what do we need to build this? We need several different objects. 3 objects we talked about: player, ball, and health potion. We need these 3 things represented in our software. So let's review. We objects and classes, it came and went real quick 2 Fridays ago. So let's do a little bit of review on objects and classes to make sure that we're ready for inheritance. So object, we have a grouping of functionality. We have state and we have behavior. We have state in these state variables and behavior through the methods, and we can put all this in an object to wrap it up all in one thing. And then the methods, the behavior, can depend on the values in the state variables. So the current state of a player is going to determine its specific behavior, because the methods are going to access its behavior through the keyword this. Here I'm just passing a reference, an entire reference of this player to my other classes, and then those other classes are going to access the state of this player. But I'm going to pass this stores a reference to the calling object, so I'm just going to give that whole reference to these other methods. Also need a ball object. State, I want the basic physics stuff, location, dimension, velocity, so it can exist in this world, it can take up space, and it can move around in this space. And then I'll be worried about the mass of the ball. I want to know when it hits another player, how much damage is it going to do? I'm going to calculate that with the mass, I decided. And then when the use method is called, I get a reference to a player, which was the calling player in the other method. The player uses the ball takes the reference of the player and determines where it's going to be thrown. And I have the orientation of the player, even though if this is applied to our physics engine, everything is orthogonal to the axes. I'm going to extract some orientation just so I can know which direction this ball should be thrown, even if for collision detection purposes we're orthogonal to the axes. So if you're wondering that, the 1 or 2 of you who were wondering that. And then we have a health potion. Again, we want to exist in the world, take up space in the world, and be able to move through the world. And here I want to track the volume. So the volume is going to determine how much health is replenished when this health potion is consumed, and making sure I don't go over the player's max health. So when this is used by a player, replenish some health. So I have these three objects. I'm going to make a game with them, but this game is going to be kind of crappy. So since I define these with objects, I can only have one player, one ball, and one health potion. You're probably not going to play that game for very long. You're going to get bored with it. You don't even have another player to throw the ball at. Not very interesting. And that's why we use classes. So when we have classes, now we have templates that we can use to create multiple objects of a particular type. I create a player class. Now I can instantiate multiple objects of type player, multiple objects of type ball, multiple objects of type health potion, and now I can have a multiplayer game with multiple items scattered throughout the game world. Now we can actually play the thing and have a little bit more fun. With a dodgeball game, we have somebody to throw balls at, and we can have a more interesting experience. So when we created classes, any state that we want the caller to be able to initialize, whoever's creating objects of this type, to initialize, we move that to the constructor. If we want these values to be accessible from the outside world, from outside of this class, we'll use either val or var, depending on whether we spec that value. We want to allow that value to change or not. And then anything that we don't want the caller to initiate, we're going to put in this zone, this area, outside of all the methods and also outside of the constructor. This is where we can add any extra initializer code. For those of you doing rhyming dictionary, it's probably where you're going to put your map. You have a question?
Why wouldn't you put it in the constructor then?
Because we don't want the caller to initialize it. So like health, we don't want the caller to be able to initialize the health and max health. Just giving me the max health, I'm initializing health to the max value. All our players are going to start at max health. So anytime we don't want the caller to specify an initial state, that's when we put it out in this area, out in no man's land outside of all the methods. Anything we want them to initialize, move to the constructor. Same with the ball, except we don't have anything that we don't want the caller to initialize. We're going to let the caller initialize all these values. We could put velocity out here and have the velocity start at 0. That'd be perfectly valid, depending on our application. But anything we want the user, the caller to initialize, throw it in the constructor. Health potion, everything in the constructor, everything is going to be initialized by the caller. Now we can use these classes to create multiple objects of this type. So we can start telling Scala, hey, create an object of type ball, get memory on RAM, and set these values to, set up all my state variables and give these initial values to the state of that ball. And I can do this multiple times and have these multiple objects exist of this type that I created using the class as a template to be able to define the state and behavior. Then gave it the initial state through the constructors. All right. Any questions on that quick review of objects and classes? Let's talk about inheritance. So we look at ball and health potion. Very similar to our situation in the lecture question. We have boombox, we have flashlight that are very similar in both state and behavior. Ball and health potion, same thing. A lot of similarity here, not identical. They do have to be separate classes, but very similar. When we see this, we can use inheritance to pull out that common functionality, put that in a separate class, and then have both of these classes borrow that functionality from the third class. And this is going to, I don't want to talk about that right now. So this is going to allow us to take all of that common behavior, put it in a third class, which is going to end up being our abstract class, and then extend this abstract class or inherit from this abstract class in both of our what we call concrete classes. There's more nomenclature involved there. But we're going to inherit this functionality. So an animate object is going to be an abstract class which stores all of these things that we need to be able to exist in this physical world. And then two methods that are going to be common in these two classes. Now, these two classes didn't have the object mass method before, but we had a ball which had mass, a health potion which had volume, which we'll use to compute its mass. So in this abstract class, we're going to say, you know what? Let's say we have a mass method, and then make each one of these implement that method. That might not make much sense the way I just said that. We'll talk a lot more at length about that specific part of it on Wednesday when we talk about polymorphism. So we create this class, this abstract class, inanimate object, give it the constructor and all the common functionality. The constructor, okay, we want location, dimension, velocity, and we're going to create these two methods. These two methods do not have definitions here, though. So I'm saying an inanimate object has an object mass method that takes no parameters and returns a tuple, and a use method that takes a player reference and returns a unit. But it's not defining what that functionality is. These are what we call abstract methods. They can't be called because they don't have any definitions. They don't have any body to the method. And whenever we have an abstract method in our class, or an abstract variable, we could do the same thing, then the class has to be abstract. What this means is that the class is not fully defined. We cannot say new inanimate object. It's not allowed. We can't create an inanimate object because its behavior is not fully defined. So it's abstract. It can't really exist on its own. It's just some abstract concept, basically. The idea of an inanimate object is just not fully defined. And then when we extend this class, we're going to inherit all of that state and behavior and then add to it in our other classes. So we're going to use this syntax, extends. When we create the ball class, well, the ball constructor as we had it before, and then the keyword extends, and then the class that we want to extend, and we're going to call the constructor of the class we're extending right in line here. So the Scala syntax for extension, create your class, constructor, extends, the extending class, and then the extending class is constructor call. So notice when I have the ball constructor now, I don't use val or var here. I'm not declaring new variables that are going to be accessed from outside of this class, because those variables, with the exception of mass, those variables are already defined in the class that we're extending. So since we're extending that class, we inherit all of those variables that were declared. Anything with val or var in the constructor, or anything outside of all the methods, we're going to inherit all of those variables, all of those state variables. So as soon as the ball extends an inanimate object, it gets location, dimension, velocity variables. And if I do this dot velocity, that's going to access this velocity that was declared here. So if I declare these again, if I have val or var here, we're going to get errors because we already have variables with those names. But we can take these with no val or var, so only accessible within the ball class, and then just forward them to the constructor of an inanimate object when we call that constructor. So we're just temporarily getting these variables named location, dimension, velocity, and forwarding them to an inanimate object. And then when we do this dot velocity, we mean this velocity over here, which got the value from this velocity. Now those methods that weren't defined, we have a contract with our abstract class. Since we extend that, we either, one, have to make this extending class abstract, meaning it's not fully defined, or we implement these methods and give them definitions, which we're going to do here. So let's override these methods. We're going to use the keyword override that says, I have some method that I inherited from some other class, and whatever functionality I got, which is none in this case, whatever functionality I got, I want to override that with this definition. So this is the new object mass method for this class. This is the new use method for this class. Then we give these definitions, since this is fully implemented now. Now, this is not an abstract class, and we can say new, we can create objects of this type. We do the same thing with health potion. Implement the methods, call the constructor, use the keyword extends, and we can borrow all of that functionality from an inanimate object, which was actually nothing here. So there's an argument to be made at this point that we just added a lot of extra code. It's a lot of extra typing. We have a new class. It seems like all we did was add complexity to our program. So certainly a valid point for this case. You probably wouldn't even want to use OOP, can I say that, for this particular example. So why are we doing this? Because when we add behavior, if I want more behavior in both of these inheriting classes, all I have to do is add it to the inanimate object method. So now as our methods get more complex, maybe we want to compute momentum, and we're going to use that object mass, which in the health potion is based on its volume, and in the ball, it's just its mass directly. So two different methods would have to be written. Now I'm just going to write one method, put it in the inanimate object class, and now ball and health potion both have a magnitude of momentum method that they can call, that they can use, that calls their object mass method, accesses that, and then returns that momentum. So now, as our methods get larger, cut and pasting this in two classes, that starts to get a little worse. And this part right here would have to be different based on the class. And then what if we want to make this game more interesting? What if we want to add 5 more types of inanimate objects? Are we going to cut and paste this method in all 7 of our classes? No, we're going to put it in one class once, type this once, and be done with it. And especially what happens when we have a method like this, you pasted it in 7 different classes, and you want to change that method a little bit. You're going to go change it in 7 different places? No, you're not going to do that. Put it in the abstract class, extend that abstract class, and then change it once and be done with it. One update, and then I change that in 7 different classes. That's the behavior we want. That's what we want when we're developing. Makes our code easy to maintain, easy to extend. If we release this game, and then a year down the road we want to release version 2.0 with some new features, we want it very easy to add those new features. We don't want to be looking at some mess of code trying to figure out where to add those features. We want to go to some base classes, add some functionality, be done. If you're doing the physics engine, we have this class named dynamic object. And a lot of the collision detection is based on these dynamic objects. As they're moving around, the physics engine will determine how dynamic objects move around and how they collide with static objects. If you do the extension, how they collide with other dynamic objects and how the momentum is preserved in these dynamic objects. We want that functionality in our game. We want our health potions, our balls, and even our players to be able to react to the physics, to have physics applied to them. No problem. We take our inanimate object class, we extend dynamic object, we call dynamic object's constructor. The constructor doesn't take a velocity, but our classes here had an initial velocity. So out here, we're going to access this dot velocity, which we inherited from dynamic object, and set it equal to the input velocity. Now dynamic object is all set up, completely compatible with our new classes. Inside physics engine, you never had to know what a health potion was, but by extending right here, and this change can be made after we have 7 different types of objects in our game. This change happens in inanimate object. Now all of our inanimate objects are compatible with our physics engine. We can take that physics engine and build this game with that engine and reuse that physics engine for a completely different application that you didn't even know about when you write that physics engine. That's the power that we get with this. So we just extend dynamic object, add balls and health potions and players to the dynamic objects list in our game world, in our world class in the physics engine, throw that world into update physics, everything works. Physics engine completely compatible with our brand new code. In dynamic object, out in no man's land over here in dynamic object, there's var velocity of type physics vector equals new physics vector, and it initializes to 0, 0, 0. It also has var, oh yeah, here we go. Var and val location and dimension. So we inherit all of those variables from dynamic object. So when I say this dot velocity, I don't have anything on screen called velocity, but in the dynamic object class, there is a state variable named velocity that was created. So we inherited that variable. Now, I am also inputting a velocity in my constructor. So importantly, if this were named velocity, I would access that variable by saying this dot velocity. But we already have a variable attached to this reference named velocity. So if I name my input velocity and I try to do this dot velocity equals this dot velocity, how do we distinguish between those two? We don't really have a good way of doing that. There are ways to do it, but they're beyond what we want to talk about today. So we just give this a different name. I just named it input velocity, and now I can refer to these two velocities differently. And when somebody from another class accesses the velocity of this, they're talking about the velocity in dynamic object. Now this is important for the homework, the lecture question. In the electronic class, you'll create a state variable named battery, and that's the one that's going to be accessed from outside of that class. So when you have a boombox with a constructor that takes in a battery in its constructor, you can't name that constructor battery, because how are you going to get that battery in the state variable inherited from electronic? So if you name that something different, and then do something like this dot battery equals whatever battery you took from your constructor, you can avoid that conflict, that naming conflict that would be caused, because you're inheriting that battery variable from the extending class, from the class you're extending. Now, those inheritance trees start making a little more sense. We have a dynamic object that's extended by inanimate objects, which is extended by two other classes. Now, each one of these classes on the bottom is an inanimate object, is a dynamic object, and has all the functionality of all of those types that it extends. So this type hierarchy, any, that's a class that's extended by every single class in Scala. Absolutely everything is of type any. Any val extends any, and that's where we get all of our, everything that extends any val, that's all our stuff that goes in the stack. And at least for now, strings you can assume is in that camp. We'll talk about that when we get to immutability. And then any ref, this is everything that's going to go on the heap, which is everything else, including your classes. If you just create a class, like the classes you've created already, without extending anything explicitly, you implicitly are extending any ref. And that's where you get methods like toString and dot equals, which is called through equal equal. And methods like that, which brings us back to our lecture question. We're about a minute over, so see you Wednesday.